Hi, I'm Joe, and welcome to an episode on an optical air quality sensor. The reason for my working with this sensor is allergies. I've got a couple people in my house who have pretty bad allergies. I never have had to suffer with those, but even I'm having problems lately. And from day to day it changes. Some days it's bad, some days it's fine. I want to start figuring out what it is and where it's coming from, and one of the steps is to measure the air quality in the house. For that, I'm using this sensor. This is a cheap breakout board I got from Amazon. The board has almost nothing on it for electronics. The whole party piece is this sensor right here, which seems to be the Sharp GP2Y1010AU0F. That's a really catchy name. But it shines a very bright LED inside and measures how much light is reflected back to the sensor. That reflection, of course, goes up as the particulate count in the air does. The idea is to take the data from this sensor and use a Wi-Fi enabled Arduino to shoot that data back to Home Assistant, which is a Linux-based operating system that I'm running on a little Raspberry Pi that handles all of my home automation. Outdoor lights turning off automatically, and the thermostat changes at certain times of day. It's really nice. I've had that set up for probably 3 years now and has worked flawlessly, and I've never had to touch it. So, integrating this into my Home Assistant system will require a little bit of relearning because I've forgotten how to do it because I've not had to tinker with it. So kudos to you, Home Assistant team. You've made software so reliable I have not had to touch it once since I set it up. I'm impressed, and I wish the rest of the software world would get on the same page you are. So grab onto your handkerchief because this eye-watering episode is brought to you by allergies. I began by breadboarding the circuit to start talking to the sensor. I decided to use Seed Studio's Xiao ESP32C3 as my microcontroller. The sensor seems pretty straightforward to use. It has 4 pins, 5 volts, ground, LED input, and an analog output. To hook up this microcontroller, I had to adapt things a little bit. The analog output is 5 volts, but the microcontroller is only 3.3 volts. So I used a pair of 10k ohm resistors to make a voltage divider. The LED pen on the sensor was a little bit more complicated. Referencing the datasheet, the LED pin is an open collector input, meaning you ground it to make the LED turn on, and it requires 20 milliamps. So the Xiao microcontroller just won't do it. For this, I have an old school 2N3904 NPN transistor with 300 ohms in series for current limiting. This only works out to be about 12 milliamps, but seems to do the job. With that all wired up, it was time to make the microcontroller say hi to the sensor. The datasheet says to turn on the internal LED, then wait 280 microseconds before taking your sample. Seems simple enough. I began in the setup function using pin mode to set the LED pin to an output, and the analog pin was set to an input by calling analog read, and the Arduino software just simply does all the rest for me in the background. I created a variable called air quality and then made a function called read air quality that simply performs all the correct steps in the correct timing to read from the sensor. I remembered to initialize the serial port, and then in the main loop had that serial port just spit out the value of the function readAirQuality, and a delay of 100 milliseconds to make the program run about 10 times per second. This was the point I realized that I was using an old version of the Arduino IDE, which didn't really work well with this microcontroller, so I switched over to the new version. And once I hit run, I had numbers. Now to find out what they mean. I need to calibrate this thing. The first step was to find the 0 point, what value the sensor gave with clean air. I took a brand new HEPA filter from my robot vacuum and cut a hole in a box and taped the filter to the box. After that, I taped the sensor inside the box and then used a small hand vacuum to suck air through the entire thing. With this, the only air that could enter the box was air that passed through the HEPA filter, and so the sensor's reading would be what I would call 0, or clean air. The rest of the calibration would have to wait until I had some sort of wireless connectivity. The Arduino connects to Ethernet via Wi-Fi using the MQTT protocol. Now, it had been a couple years since I've done this, so I couldn't really remember how. So I simply opened up one of my old project files for a temperature sensor and copied and pasted the code into place. Don't look at me like that, you've done it too. It was the same story for the YAML configuration, but fortunately, it all worked on the first try. Which I was really glad of because I didn't want to have to try to relearn all that to debug it. And after soldering everything up, with the inclusion of a small cooling fan to drive air through the sensor, I was able to do the other part of the calibration. I took the unit outside and set it out on the barbecue and watched what the input was, and then looked up the reported air quality in the area. After learning more than I ever needed to know about air quality and a few mathematical gyrations, I was able to get a very decent output. The only thing left was to make a decent housing for this. So I jumped into my CAD program and started modeling something out and sent it off to my brother to be printed, which he was able to bring over to me later that day. When it came to assembling the housing, everything had nice screw holes, so I did what any sensible person would do and just simply hot glued everything in place. But it works really well. And there it is, my USB powered but otherwise wireless dust sensor for Home Assistant. Let me know in the comments if you want to see more about making Arduino-based Home Assistant devices. And remember to order new filters for your vacuums and stuff. I definitely have a bunch on the way. So until next time, happy breathing. I'm Joe. Please like the video if you liked it. Subscribe if you want to see more. Signing off.